Hi everyone, welcome to this video. I hope you had watched the video that I went over example 7. All right, so here is another example. It is very similar, but I thought it would be nice for me to show you guys another example. Um, so let's get to it. So please pause the video and take a look at the question that we have here. Okay, welcome back. Cool. So but by now we should all be pretty fluent with using the right math notations for binomial distribution. So it says that 1% of fusers in a large box are faulty. Right? So our P is 0.01. And they're asking us to find the largest sample size. They want us to find the N. So that the probability where there are no faulty fuses. I have underlined this for you. Feel free to do the same when you are solving questions or taking the quizzes or tests. And that no faulty fuses, the probability for no faulty fuses must be greater than 0.5. All right, so let's start with the math notation. So I know that my X is binomially distributed, and my N, which is something we need to find, and the 0.01 that is given to us as the probability. So always keep in mind of what your random variable X represent. And in this case, the random variable X represents the number of boxes. Okay, how many boxes are we gonna check so that the probability that we don't find any faulty fuses in this n number of boxes that we check will be more than 0.5. Okay, so pretty much you can think of this as, is it the more we check, the higher the probability that we have no faulty fuse, or is it the less we check, the higher the probability with no faulty fuse? That's kind of what the question is trying to imply, right? Okay, so let's get back to the math part. So they said they want us to find the probability. They want us to find the N. How many boxes should we check so that the probability where there are no faulty fuse means my X is equal to 0. Right? The probability for that to happen must be greater than 0.5. So that's what this means. Yeah. So at this point, I can use my GDC. So please take yours out too as well. And I'm going to use the table function to help me out. Okay. So let's go to Y first. I have, I'm going to go to Bino PDF. So second vars brings me to distribution. And I'm going to pick Bino PDF. Trials, I don't know. That's what we have to find. P is 0.01. The X value, we're looking for X equals to 0, right? 0 faulty. And that's my Y1. And just go to table for now. So second graph gives you a table. And we can scroll down. And we're looking for the largest sample size that will give us a probability that's more than 0.5. Yeah. So we just scroll down. As you can see, the more we scroll down, the bigger the X, or the X over here, that represents my N, right? So higher the N, the smaller the probability. So let's go, let's see. Let's scroll all the way down. And we're looking for 0.5. 0.5, 0.5. Oh, we're getting close. There you go. So the first time that we see 0.5 is when my n is 68. So that's it. That's my answer. Yeah. So n equals to 68. If we asked, if we pick 68 boxes, we will be able to have. We would be able to have 0.505, maybe 0.505 chance of getting no faulty fuse out of the 68 boxes. Okay, so what does that mean? If you see that when I open up more boxes, so right now the answer is 68, but if I open up 69, or if I open up more boxes, let's say 80, you can see that the probability for me to get no faulty fuse drops, right? So in other words, let's say I'm trying to impress my supplier, right? I'm trying to impress not my supplier. I'm the supplier of the fuses. I'm trying to impress my buyer, my customer. I would not want to open the boxes for them to check. The maximum I'm going to allow them to check, let's say the 0.5, the probability of 0.5, let's say that's the decision mark, right? And I would not want to let them open up I would not want to let them open up 69 boxes or onwards, because once they open up 68 boxes, that's the ultimate box that they can open, and yet my probability is going to be more than 0.5. So please always try to bring back to the context, because it gives meaning to what you have found. Otherwise, they are just numbers flying around, numbers that you are punching in the calculator. Okay, hope you guys found this video helpful. I'll see you guys in the next one. Bye bye.